we can use this binary system to represent larger numbers. And so we've already talked about how computers often organize their data in bytes, and so that's a group of 8 bits. And so if we go back and look at these numbers, each one of these, not the one with the decimal, but like this one, so like if we have the 1101, each one of those numbers would have its own bit. So this would really be a 4-bit number here. And so if we have a group of 4 bits, that's called a nibble, but I haven't really heard that term all that much. A group of 8 bits is a byte. And if we look at a byte here, this is the most significant, so these are normally numbered as like the least significant bit is on the right and the most significant bit is on the left. So if you hear people refer to least significant bit, that means that they're referring to this bit here on the left. And if they're referring to most significant bit, they're referring to this bit here on the left, and this one's on the right. And so we can use this formula to convert from whatever our number is, our binary number, so whatever number is stored in the byte, to a decimal number. And this is the formula we were just using. So if let's say that we have a byte, so we have 8 bits, what's the maximum number that we can store in that? Let's write this out. So here's my byte, and I have a 1 stored in each byte. And then if I go look at how they're numbered on this figure of a byte, I know that I can represent this. So this is 1, so 0, 1, 2, 3, 4, 5, 6, 7. So then all I need to do is apply this formula to basically figure out what this number is, because this is the largest number that we can store in that byte. And so that would be A7 is 1. So I have 1 and then times 2 to the 7th plus 1 times 2 to the 6th. And all of these A's in this formula are going to be 1s because we have a 1 stored in every bit. So plus 1 times 2 to the 5th plus 1 times 2 to the 4th plus 1 times 2 to the 3rd plus 1 times 2 squared plus 1 times 2, 1 plus 1 times 2, 0. And if you work through that, you get 255. So 255 is the maximum number we can store in this byte. And so what is the next question is, what is the range of values, like what range of values can we potentially store in this byte? 0 to 255. So if we want to store values larger than 255, we can group bytes together. So this is where you hear like the 32-bit or 64-bit. And so let's say that we have 2 bytes, assuming that it's a positive number. What's the largest number we could store in that? So if we have 2 bytes, so I'm going to draw the bytes. So 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. Sorry, that's kind of messy, but this is our binary number. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So seeing it written like this, now tell me how many, like what's the largest number, like basically what is this number? Because this is the largest number we can store in 16 bits or 2 bytes. So we can store 65,535. So that means that within the 16 bits or 2 bytes, we can store a range of values between 0 to 65,535.